All right, class, welcome. If you've ever built an Arduino project, you know just how crucial it is to get clear visual feedback. So today, we're going to master a component that does this brilliantly, the KY-011 two-color LED module. Trust me, by the end of this, you'll be adding professional-level status indicators to any of their builds.
So here's our game plan. We'll start with what this little module actually is, then we'll cover the super important safety steps so you don't fry anything. After that, we get our hands dirty with wiring and code, first with simple on-off stuff, and then we'll get into some really slick analog techniques for mixing colors. Let's dive in.
Okay, first things first. Before we even dream of plugging in a wire, we've got to understand the component itself. So what exactly is this thing, and why should you even have it in your parts kit? Well, the KY-011 isn't just one LED. Nope, it's actually two completely separate emitters, one red and one green, cleverly packed into a single tiny housing. This two-in-one design is just perfect for projects where you need clear, simple signals, like a status light or a warning indicator.
All right, let's dig into the electrical principles. Now listen up, because understanding how this thing is wired internally is absolutely critical. I'm serious. Get this part right and your project works like a charm. Get it wrong and you might just see that dreaded puff of magic smoke. The secret sauce to this module's design is what we call a common cathode. You can see it in the diagram. Both the red and the green LEDs are tied together on the negative side. This is a really clever bit of engineering, and it's what's going to make our wiring so much easier.
So, in simple terms, common cathode just means they share a ground connection. What does that mean for us? Well, instead of needing 4 wires, a positive and a negative for each color, we only need 3. One signal for red, one for green, and that one single shared ground pin. See? Much cleaner. And this schematic lays it all out. That common cathode pin goes straight to our circuit's ground. Then, all we have to do is send a positive voltage to the red pin to light up red, or the green pin to light up green. It's a really efficient, straightforward design. Now, this brings us to probably the most important question you have to ask anytime you're working with LEDs. The Arduino pushes out a 5-volt signal, so can we just hook this module right up to the pins?
The answer is a huge, emphatic no. And I cannot stress this enough. It is absolutely critical that you use a resistor in series to limit the current. If you don't, that LED will try to drink way too much power from the Arduino and it will burn out instantly. Game over. And the key is using the right resistor. For a standard 5-volt Arduino like an Uno, you need a 220 ohm resistor. And not just one, you need one on each of the signal lines. One for the red, one for the green. Don't eyeball it, don't skip this step. It is absolutely mandatory if you want to protect your parts.
Okay, enough theory. We've covered the safety rules. Now it's time to get our hands dirty and actually build this thing. We're going to move from the drawing board to the breadboard. Let's trace these connections together. The red signal wire connects to digital pin 10. The green signal goes to pin 9. But look closely. What's the most important part? You see it? Each of those lines runs through its own 220 ohm resistor. Then, that third pin, our common cathode, goes straight to the Arduino's ground.
I love this slide because it shows the two sides of the coin. On the left, you've got the physical build on the breadboard. On the right, you've got the schematic. Learning to translate between these two is a vital skill. They look totally different, but they're telling the exact same story.
All right, our hardware is wired up and ready to go. Now it's time to give our circuit a brain. We're going to jump into the code and start with the most fundamental type of control there is, simple digital signals.
The logic here is about as simple as it gets. Think of it like a light switch. When we send a high signal from our Arduino, that's like flipping the switch on. It sends 5 volts down the wire and the LED lights up. When we send a low signal, that's like flipping the switch off. It drops the voltage to 0 and the light goes out.
So here's the code that brings that idea to life. This simple little program does one thing. It makes an alternating blinker. The red light comes on for 3 seconds, then it turns off and the green light comes on for 3 seconds, and it just repeats that forever. Let's pull back the curtain and see how it works.
The code really just follows 4 basic steps. First, we give our pins some easy-to-remember names. Then, in the setup block, we tell the Arduino, hey, these 2 pins are going to be outputs. Then, in our main loop, we use that digital write command to turn one light on and the other off. And finally, we use delay to just pause before it swaps them.
Now, simple on and off is great. It's the foundation. But what if we want a little more finesse? What if we want to control the brightness? Or, even cooler, mix red and green to get yellow or orange? Well, to do that, we need to go beyond digital and use a powerful trick called pulse width modulation, or PWM. PWM is a fantastic illusion. The Arduino is actually blinking the LED on and off thousands of times a second, way too fast for our eyes to see. And because of how our brains work, we don't see the blinking, we average it out, and we perceive it as a change in brightness. The longer it's on in each cycle, the brighter it looks. It's a really neat hack.
And the command that unlocks the superpower is analog write. See, digital write is just on or off, but analog write is like a dimmer switch. It gives us 256 levels of brightness, from 0 for off all the way to 255 for full brightness. This code uses a for loop to just walk through all those values and create that awesome smooth fade.
The real magic behind that beautiful color gradient is this inverse relationship. Take a look at the code. We have a variable, I, that controls the green LED. As I goes down, the value we send to the red LED, which is 255 minus I, goes up. They're like two ends of a seesaw. As one smoothly fades down, the other smoothly fades up, giving us that perfect gradient.
Okay, so now you've got the theory, the hardware, and the software for both on-off control and fancy analog fading. So, what do we do with it? Where would you actually use this in a real project? Let's talk applications. This module is an absolute rock star at communicating status at a glance. You can use solid green for system OK, a flashing red for warning error, or you can use that PWM trick to mix an orange or yellow for things like processing or standby. It's all about clear, instant visual communication. So, before you dive into your next big project, just run through this final checklist. Number 1, polarity matters. Make sure that common cathode goes to ground. Number 2, resistors. Always use the correct resistors. And number 3, pick the right tool for the job. Digital write for on-off, analog write for fades and color mixing. And I'll leave you with that question to think about. Look, the goal here isn't just to make a light blink. The real goal is to make that light communicate something useful. So think about it. What important message will your next project send to the world?
Hello and welcome back. Today, we're diving into a really fantastic and versatile little component, the KY-011 two-color LED module. We're going to take this thing right out of the bag and turn it into a fully functioning, color-fading light. And we'll do it all with just a few simple lines of Arduino code. So, let's get right into it.
So here's our game plan. First, we'll get properly introduced to the KY-011 module. Then, we're going to wire up our circuit, write some code to make it blink, and after that, we'll level up and create a really cool color fading effect. And finally, we'll talk about what you can build with these new skills.
All right, first things first. What exactly is this little guy? It might look pretty simple, but trust me, it's the key to adding awesome visual feedback to just about any project you can dream up.
Now, the real magic here is in its design. It's got both a red and a green LED packed into one single unit. They're connected by what we call a common cathode. All that means is they share the same ground connection. You can think of it like having two separate lamps that both plug into the same outlet. It just makes the wiring a whole lot cleaner.
Okay, let's peek at the tech specs really quick. The forward voltage is basically the amount of electrical push it needs to light up, and the forward current is how much electricity it's going to use. These numbers are super important for making sure we pick the right components to protect our LEDs down the line.
So what can you actually do with this? Well, pretty much anything where you need some kind of visual feedback. You could use it as a simple status indicator, green for everything's good, red for uh-oh, or for warning signals, control systems. Really, it's just a simple, effective way to make your project talk to you.
All right, enough talk. Let's get our hands dirty and actually wire this thing up. It's time to connect the KY-011 to our Arduino.
The pin out for this is incredibly simple, which is great. The pin marked GND obviously goes to the ground on the Arduino. Then we'll connect the green LED's pin to digital pin 9 on the Arduino, and the red LED's pin goes to digital pin 10. Yep, it's really that easy. Now, this next port is absolutely crucial, so listen up. You cannot forget the resistors. The Arduino puts out 5 volts, and that's way too much power for our little LEDs. A 220 ohm resistor for each color will limit that current and stop them from burning out. Seriously, this is a non-negotiable step.
Let's just walk through it one more time to be sure. Step 1, connect the ground pins together.
Step 2. Run a wire from Arduino pin 9 through a 220 ohm resistor and then to the green LED pin. Step 3. Do the exact same thing for the red LED, connecting it from Arduino pin 10 through its own resistor. And that's it. Our circuit is done.
Okay, with the hardware all sorted, it's time to jump over to the computer and write some code. In just a second, we're going to bring this circuit to life with a good old-fashioned blinking pattern. So every Arduino program has two main parts. The first one is the setup function. This code only runs one single time, right when you power up the Arduino. Here, we use the pin mode command to basically tell the Arduino, hey, listen up, I'm going to be using pins 9 and 10 to send signals out to control my LEDs.
The second part is the loop function, and as the name suggests, this part just runs over and over and over again, forever. Inside this loop, we turn the red LED on and the green one off. Then we wait for 3 seconds. After that, we just swap them. Turn the red LED off and the green one on, and that gives us our classic blinking pattern, flipping between red and green.
Blinking is cool and all, but what if we wanted something a little more elegant? Now we're going to go beyond just on and off and create a really smooth, beautiful fade between red and green.
So, to get that fading effect, we use a clever trick called pulse width modulation, or PWM. Instead of a steady on or off signal, PWM is like a super fast light switch. It's flashing the LED thousands of times per second. Our eyes can't actually see the blinking, so they average it out and we perceive it as a change in brightness. It's how we create a smooth dimming effect.
So in our code, we'll use a for loop along with the analog write command. This loop is going to smoothly shift the brightness from full green all the way to full red. It does this by slowly stepping the green LED's brightness value down from 255 to 0, while at the same time, it's stepping the red LED's brightness up.
But we don't want the light to just snap back to green, right? That would ruin the effect. So we add a second for loop that does the whole thing in reverse. This loop fades the red LED back out while bringing the green LED back in. The two loops together create this awesome, continuous, seamless color fading cycle. And there you have it. We've gone from a simple little component to a dynamic, color-changing display. So now the question isn't just how it works, but what you can actually do with this knowledge.
Let's do a quick recap of everything we accomplished. We learned all about the KY-011 module and its common cathode design. We wired it up the right way, with resistors to our Arduino. We programmed a basic on-off blinking pattern. And then we took it to the next level by creating a smooth color fade using the power of PWM. That's a whole lot of ground we just covered.
You now have the skills to add some really sophisticated visual feedback to any project you can think of. I mean, you could build a temperature monitor that fades from green to red as things get warmer, or a system status light for your computer, or even some kind of custom interactive art piece. The possibilities are endless. So the only question left is, what will you build?